In this lesson, we are going to solve this question I have on the screen, which says that for all n values greater than or equal to 1, prove that this series you have on the left hand side here because of this expression you have on the right hand side. So now let's look at how we are going to do this. Okay, so first of all, we have to test whether this is true for the first n values. Okay, so we have the n values to be equal to 1, 2, 3, and so on. So first of all, we are going to consider n to be equal to 1, and we are going to see that whether this equation is true. So when n equals 1, we are going to consider the first term in the series, which is 1 to the power 2. Okay, and that should be equal to the expression on the right hand side when you substitute n equals 1 into it. So you have 1 to bracket 1 plus 1. Okay, multiplying 2 to bracket 1 plus 1. Okay, so you're going to divide all this by 6. So what you're going to do is that you're going to check whether the value on the left hand side equals the value on the right hand side. 1 squared is this much 1, and this will be equal to 1 plus 1 is 2. Multiplying 1 will give us 2. And then 2 multiplying 1 will give us 2. Plus this one here, that will be 3. So that will be 2 times 3 divided by 6. So this will be equal to 6 over 6. And that will be equal to 1. So therefore the value on the left hand side equals the value on the right hand side. So it is true for the first n values. Okay, so now since it is true for n equals 1, we are going to assume that it is true for a certain value n equals k, where k is also greater than or equal to 1. So we are going to assume true for n equals k, where k is greater than or equal to 1. So therefore you have 1 plus 2 to the power 2 plus 3 to the power 2 plus all the way to k squared. This should be equal to k multiplied k plus 1 times 2k plus 1. Okay, all this divided by 6. Okay, I didn't raise this 1 to the power 2 because 1 to the power 2 will still give us 1. Okay, so you are going to assume that it is true for n equals k. So the next thing that you are going to do is that if it is true for n equals k, then we will have to prove that it will be true for the next value that comes after k, which will be k plus 1. So you are going to show that it is true for n equals k plus 1. Okay, I'm going to show that it is true for n equals k plus 1 also. So now we have the series to be 1 to the power 2 plus 2 to the power 2. Okay, then plus 3 to the power 2, then plus all the way to k squared, and then plus k plus 1 squared. Okay, so this will be equal to k plus 1 multiplying k plus 1 plus 1, okay, times 2 into bracket k plus 1 plus 1. Okay, so all this divided by all this divided by 6. Okay, so what I'll do here next is that I'm going to simplify what you have on the right hand side. So this will be equal to k plus 1. Okay, multiplying when I bring these values out of the brackets, we will now have k plus 2. Okay, because this one here will add up to this one here, and then multiplying this is these two will multiply this k, that will be 2k, and then it will multiply this one here, so that was 2k plus 2 plus this one here, so that was 2k plus 3. So all this divided by what? 6. Okay, so let's leave this here. Okay, so from the step 3 here, okay, I'll name this what? Step 3. Then I'll name this step 2. Then let's name this step 1. Okay, so from step 3 here, okay, we know that what? 1, okay, let me make it 1 to the power 2, okay, plus 2 to the power 2 plus 3 to the power 2 equals what? Sorry, I missed plus all the way to plus k to the power 2 plus what? K plus 1 to the power 2 to the power 2 equals what we have here, okay, which is what? K plus 1 multiply with k plus 2 multiply with 2k plus what? 3, all divided by what? 6. Okay, so that's what you have now. Okay, so now let's go back to what? Step 2 also. So from step 2, we know that what? All these values that we have here, okay, equals what? What we have here, right? Because you can see from the left hand side here. So instead of using all that we have here, you can come and substitute this value here. Okay, so you have what? K multiply with k plus 1 multiply another bracket 2k plus 1 divided by what? 6, then plus k plus 1 squared should be equal to what you have on the right hand side, which is what? K plus 1 multiply with k plus 2 multiplying 2k plus 3. All this divided by what? 6. Okay, so the only thing you have to do here is that you will have to what? Prove out what? This value here is equal to what? This value here. Okay, so let's do that. Okay, so now, so I'm going to prove out the value on the what? On the left hand side equals what? The value on the what? On the right hand side. So let's do that. So I'm going to consider this value on the left hand side, which is what? K multiply with k plus 1 multiply with 2k plus 1 divided by what? 6 plus k plus 1 k plus 1 what? Squared. Okay, so what I'll do is that I'm going to add these two values here. Okay, and I'll do this by what? Multiplying what? The denominators. Okay, you know this is divided by what? 1. So I'll multiply this is by this one, and that'll give me what? 6. And then I'm going to do cross multiplication here. So I'll multiply this value here by this one, then I'll multiply the 6 by what I have here. So that'll give me what? K multiplying k plus 1 times what? 2k plus 1. Okay, then plus 6 multiply with k plus 1 all squared. Okay, so at the end you see that what? K plus 1 is common to what? Both terms here. Okay, so we're going to factor k plus 1 out. So at the end you have what? K plus 1. Okay, multiplying what? K into bracket 2k plus 1. Okay, then you have what? Plus 6 multiply with k plus 1. So all this divided by what? 6. So let's go ahead and then simplify it again. So you have what? K plus 1 multiply what? This k multiply what? This 2 here, this 2k, that gives us what? 2k squared. Okay, and then plus what? This k multiply 1, that gives us what? Plus k. And then you have what? Plus 6k plus what? 6. So all this divided by what? 6. Okay, so let's continue. So we have what? K plus 1. Okay, then from here let's simplify what you have what in this bracket here. So that gives what? 2k squared plus 7k plus 6. Okay, so what is divided by what? 6. So let's focus on what you have what in this bracket here. So I'm going to write this as what? K plus 1 multiply with 2k squared plus 4k plus 3k plus 6. Okay, so all this divided by what? 6. So you see that what you have on this side here, okay, the same as what you have here. Okay, it was this 7 that I split into what? 4k plus what? 3k. Okay, so it's the same thing. So what I'm going to do next is that I'm going to what? Factor out what? This polynomial that we have here. Okay, so we have what? K plus 1. Okay, multiplying what? So I'm going to what? Group them. Okay, so that'll be I'll group this and then group this also. So from here I'm going to what? Factor out what? 2k. Okay, so that what? 2k multiply what? K plus what? 2. And then from here also I'm going to factor out 3. So that what? Plus 3 out multiply what? K plus what? 2. Okay, okay. So all this divided by what? 6. Okay. So now let's continue from this side here. So we have what? K plus 1. Okay. Multiply what? 2k bracket of k plus 2. Okay. Then plus 3 multiply what? K plus what? 2. Okay. So all this divided by what? 6. Okay. This is what you have here now. So I'm going to rewrite this as what? K plus 1. Okay. Multiplying what? So we factor this value that we have here. So that what? Multiply what? 2k plus 3. Okay. And then times what? K plus what? 2. All this divided by what? 6. So this will be equal to what? K plus 1 times 2k plus 3 times what? K plus what? 2. So all this divided by what? 6. So then you see that what we have here, okay, it is same as what we have here, right? You have what? K plus 1 in it, you have what? 2k plus 3 in both also, and then you have what? K plus 2 in both. So therefore we have been able to prove that the values on the left hand side is equal to the expression on the right hand side when you have what? N to be equal to what? K plus 1. So therefore the statement is true for all n values greater than or equal to 1. So we are going to see that 1 to the power 2 plus 2 to the power 2 plus 3 to the power 2 plus all the way to n equals n to bracket what? N plus 1 multiply with 2n plus 1 about 6 is true for all n values greater than or equal to what? 1.